Hello, my wonderful AP Chem students. So I really hope that you watched the video before class today because it's going to be extra helpful. There was it was technically review, but there was a lot of hard concepts that we covered in the video. And this one went over both 4.2 net ionic equations and 4.3 representations of reactions, and really the video didn't even get to this one, and so we'll talk about that right now. I do also want to say that in AP Chem, when they want you to solve for the net ionic equation, they often don't say those exact words. They will often not say what's the net ionic reaction, but instead they'll say what is the reacting species, or what are the things that are actually reacting, like get rid of the spectator ions. And you'll see that quite a bit today when you do the practice problems. Before we dive into the practice problems though, I'd like you to go to page 12, and we're gonna do this one together. So we have silver nitrate and sodium chromate here. Okay, now, really is so important that you know these polyatomic ions so you can recognize them. But like, let's say that we forgot nitrate. Okay, we see that it's with silver, and silver is one of 3 transition metals that I really need you to know their charge. So yes, aluminum is in group 13, which has a +3 charge, but then diagonally from here, zinc you also need to know, and silver you need to know. So it's going to go +3 for aluminum, +2 for zinc, and +1 for silver. +3, +2, +1. So silver is going to form an ion that's a +1. And notice how we just have a single nitrate with it. There's not 2 of those nitrates, just 1, and so it must also be a +1. And we know that, or sorry, a -1. It must also be a -1. And we know this, it's NO3 -1. That's what nitrate is. Okay? Sodium, because it's in group 1, is a +1. But do you see how there's 2 of them this time? So this chromate, the CrO4, it must be a 2-, because you see if we crisscross how we would get the 1 chromate and the 2 sodium. And whenever we have 2 ionic things, they will switch partners. So instead of the silver being with the nitrate, now the silver is going to be with the chromate. And instead of the sodium being with the chromate, now it's going to switch and it's going to be with the nitrate. So we have 2 new ionic solutions here. But which ones are soluble in water? Which ones are going to continue to be aqueous just like this guy is? We're going to dive more into solubility rules later, but what I want you to know right now is the group 1 metals, whatever ionic compound they're with, they tend to be soluble, definitely sodium. And then nitrate is also something that's really soluble. So we can see that this guy had nitrate, and so it was soluble, aqueous. This guy had sodium, it was soluble, that one's aqueous. And then this is double whammy, it's both sodium and nitrate, that is definitely aqueous. And what we have left over doesn't have the sodium or the nitrate. It doesn't have any group 1 metal or the nitrate. And so this is probably going to be our precipitate. It's probably going to be solid. So I need a net ionic equation. I need to write a reaction that only is representing the reacting species. When we have a metal and a nonmetal, or a metal and a polyatomic ion, when they are aqueous, that means that they will break apart. And let's balance this. So 2 silver, and then this is 2 nitrate, and then 2 sodium, 1 chromate. Okay. So before I do the net ionic, I'm going to do the complete complete ionic, not just the net ionic. So I'm going to have 2 of these silver ions. They are aqueous. And again, I'm breaking this apart because it's an ionic compound and it's aqueous. And there's also going to be 2 nitrates ions, aqueous, plus 2 sodium ions. Yes, it's a subscript there, but it's not a polyatomic ion, so there's 2 of those sodiums. And then there's 1 of the chromate, CrO4, 2 minus. Okay. Also aqueous. Now when it's a solid, a liquid, or a gas, not aqueous, then I leave it together. So we have 2 of the silver chromates, CrO4, solid. And then we're going back to our ions again. 2 sodiums, aqueous, and 2 nitrates, aqueous. Okay, it's a lot. What are the spectator ions? They're the ones that are showing up on both sides. And I'm seeing nitrate, and seeing sodium, and sodium. And so nitrate was a spectator ion. It was there in the beginning and it was there in the end. And sodium was a spectator ion. So if we cancel that, then we're going to be left with our net ionic, or the reacting species, and that's 2 silver ions aqueous. I'm canceling this and canceling this. And 1 chromate ion aqueous turns into 2 silver chromate solid. Okay, let's try one more. The color of silver iodide solid, and notice this is kind of speaking to what we were talking about, that the silver and the iodine, doesn't have a nitrate and doesn't have a group 1 metal, and it's listing it as a solid. This is not a perfect rule that I'm telling you, but it works quite well. A student adds a solution of sodium iodide to a test tube containing a small amount of solid cream-colored silver bromide. After stirring the contents of the test tube, the student observes that the solid in the test tube changed color from cream to yellow. So a student adds a solution. So we have this sodium iodine, and it's a solution, so it's aqueous, dissolved in water, to a test tube containing a small amount of solid silver bromide. So NaBr, solid. After stirring the contents of the test tube, the student observes that the solid in the test tube changed color. Okay. So this positive sodium is no longer going to be with the negative iodine. This positive sodium this guy, I wrote sodium bromide, but this is supposed to be silver bromide. So we have sodium iodine with a small amount of silver bromide, AgBr, my bad. So this positive sodium is not going to be with the negative iodine. The positive sodium is now going to go with the negative bromine. And then this positive silver is going to go with the negative iodine. I need to know the charges of these things. So sodium's a +1 because it's in group 1. Bromine's a -1 because it's in group 17. Aluminum is a +3, +2, +1, so silver's a +1. And then the other one was iodine, which is also in group 17, so it's a -1. So we have a +1 and a -1, so if I crisscross, it's just 1 to 1. And then a +1 and a -1, so if I crisscross, it's just 1 to 1. However, it's saying that there is a solid. One of these has to be solid. And reminder, group 1 ionic compounds tend to be aqueous, not solid. So I bet this is our solid. And it makes sense because they're saying that this new solid is yellow, and the very first sentence there is the color of silver iodide is yellow. So I think this is the chemical reaction, and I don't need to balance it. It's already balanced. So then what would the net ionic be? Well, these aqueous ones we need to break apart. Like we have the sodium aqueous plus iodine aqueous plus silver bromide solid turns into sodium aqueous bromine aqueous plus silver iodine solid. And this go around, there's only one spectator ion. There's only one ion that's present at the beginning and the end that we can cancel, and so that our net ionic is iodine minus aqueous plus silver bromide solid turns into bromine minus aqueous plus silver iodine solid. Okay, great. Now, we need to look at the practice problems together. So if you don't have this, go and grab it. Okay. The 4.2 and 4.3 practice problems. So there's a couple of questions I want to do with you, and there's some things that I had to provide you with some information beforehand. So can we please jump to number 4? So number 4 is talking about how they are taking these samples of eggshell that have some calcium carbonate in it, and they're taking that calcium carbonate and adding some hydrochloric acid, this HCl, and a chemical reaction is occurring. And because we haven't talked enough about how acids and bases react, you wouldn't right away know what this chemical reaction is. So what I'm going to do is I'm going to tell you what the chemical reaction is, and then I want you, from that complete chemical reaction, to figure out the net ionic solution. And notice the phrasing, just like I was telling you. It says, which of the following equations best represents the species that react? Okay, and the species that react, aka they want not the complete, but the net ionic equation. So I need to tell you that calcium carbonate, solid, is going to react with hydrochloric acid, and that's going to turn into calcium chloride plus H2O gas plus CO2 gas. Okay? I have not balanced that equation. You need to check if it's a balanced equation, and if it's not, balance it, and then go through and get rid of any spectator ions. Okay? If there's any spectator ions, then you need to get rid of the spectator ions. And I'm just also realizing that I need to tell you, we're going to go over this in much more detail later, but strong acids and strong bases also break apart into their ions. So this guy you need to break apart into an H plus aqueous and a Cl minus aqueous. And then you should already know this is a metal and a nonmetal, so this is an ionic compound and it's aqueous. So you're going to have to break apart the calcium 2 plus aqueous and 2 of the Cl minus aqueous. Okay. So I'm going to let you take it from there, and then I'll finish this one so you can check the key. Okay, similar idea. I need to provide you with a little more information. Look at number 6. So in number 6, again, it's asking for the reacting species. It's saying, which of the following equations best represents the reacting species in the reaction between zinc metal and nickel chloride aqueous. So this is what I'm going to tell you. When you have a metal that's a solid and it's reacting with an aqueous solution, that metal is going to replace the other metal, and then the other metal is going to become a solid. So see how the zinc solid reacts with nickel chloride to form zinc chloride and then nickel solid. Okay? You need to crisscross for the charges. Like zinc based on location is a 2+ and chlorine's a 1-, so that's why I have the subscript of 2. So that's going to be the reaction that then you find the net ionic equation for. Okay, and similar, number 7, we're dealing with another strong acid. So I'm going to tell you that the equation is magnesium solid plus HCl turns into H2 plus MgCl2 aqueous. That's the reaction. You need to balance it, and then you need to figure out the net ionic. And don't forget to break apart this strong acid, the HCl, break that apart into an H+ and a Cl-. There's one more like that I need to talk to you about, and that's number 9. Talk to you about 7 and 9. Okay, that's number 9. All right. So, if you want to skip number 9, that's okay. We're going to talk more about acids and bases later, and this is an acid-base reaction. But HC2H3O2 is a weak acid. Sodium hydroxide is a strong base. And so when an acid or a base is weak, even though it says aqueous, we don't break it apart. But when an acid or a base is strong, then we do break it apart. So this would break apart into sodium plus and OH minus aqueous. And whenever an acid and a base react, it doesn't matter if it's a strong acid, strong base, weak acid, weak base, or some combination of those. You will always get water and an ionic compound. And so this is what that ionic compound ends up being. Ends up being sodium and then C2H3O2. And so everyone, let's talk more about number 9 later when we go over acid and base reactions, but the answer to that one is C. Okay, last thing before you dive into this on your own. Number 11 is missing something. So if you look at number 11, it says a mixture of CO and O2 is placed in a container as shown above, and then it doesn't show you one above. So will you please draw this? This is the image that should have been there that's showing you above. This is before the chemical reaction occurs. And so the colored in, that one is carbon, and then the ones that are not colored in, that's the oxygen. Count how many molecules we have. We got 1, 2, 3, 4 of the CO molecules, and we got 3 of the O2 molecules. And I want to show you this. So the chemical reaction for this is 2 CO molecules plus 1 O2 results in 2 carbon dioxide. Okay? That 2 carbon monoxides plus 1 O2 will make 2 carbon dioxides. So think of this as my recipe. This recipe tells me that I need 2 carbon monoxides and 1 O2, and that's going to make 2 carbon dioxides. So this is my recipe. These are my ingredients. These are the ingredients I have in front of me. And again, the recipe told me that for 2 carbon monoxides and 1 oxygen, that combination right there is going to make 2 of the carbon dioxides. It's going to make this guy, and it's going to make that guy right there. And then I look back at my ingredients and I say, do I have enough ingredients to run this recipe again? And I go, yeah, sure enough, I do. There's 2 carbon monoxides plus 1 O2, and that's going to make 2 more carbon dioxides, this one and this one. But I had something left over that didn't react. And that's okay, but it can't just pop out of existence. It can't just like disappear. If it was there in the beginning, then it also has to be there in the end. So that would mean that from these reactants, I was able to make that product. I'll have you try this on with your group on 12, same with 13 through 15. Okay? And then we got our free response. And I think our free response was good to go. This one's going to take you a little bit longer today. You can totally get through it all, but you are going to have to work diligently on this, especially where it's a homeroom day today, I believe. And so work hard. You'll be able to get this done. And then if you have any extra time, you can work on any of your Unit 3 corrections, any of the tests from Unit 3. So I'll try to get those answer keys at the front for the tests as well, so you can use those to work on your corrections. So while you're doing the practice problems, you're with your groups, working on this, getting this done, checking your work often, lots of collaboration, and then if you get this done, then you can move seats and work with who you'd like to finish your Unit 3 test corrections. Okay, everyone, I'm excited to see you all next week. Work hard today, and then again, I'm at that writing conference thing, working on that test, but I should be able to respond to emails, so if you have any questions, don't hesitate to reach out, and I'll see you all next week.